So I just wanted to go through a review of tangent lines and making sure that we all are still kind of on board and understanding what exactly it is that we're trying to accomplish with finding equations of tangent lines. So since unit one, the end of unit one, as soon as you started taking derivatives, we were looking at finding the equation of a tangent line to the graph of a function y equals f of x at a particular point. And the way I've drawn this point is at x1, y1. All right. And the way that we did that was we used the point slope form and we said, the slope of this tangent line we could find using derivatives. So just to go back real quick, the way that we found the slope of the tangent line was to say, move this down, sorry. The derivative of the function specifically evaluated at x1. Okay. And so if you wanted to rewrite this point slope form a little bit more carefully, you would say y minus y1 equals f prime of x1 times x minus x1. In other words, you would use the derivative at the point in place of the slope notation m. Okay, but it's the same idea. All right. So what I'm going to do is I'm actually just going to redraw this entire scenario. And we're going to go ahead and just change the name of the value for x at which we are looking for the tangent line. And just so that we can be in alignment with the worksheets and the textbook and everything else, I'm going to go ahead and call it A. So A is the point at which I would like to find the equation of the tangent line. So I'm going to go ahead and draw myself a tangent line here. Okay. And the y value at this coordinate point, instead of saying y1, I could say the y value is when I evaluate the function f at the value for a. So the y value here would be f evaluated at a. Okay. And then I could also say that the slope of the tangent line here is the derivative of the function evaluated at a. Okay. So there's actually nothing different about what I'm doing here other than the formatting, the language that I'm using. Instead of x1, y1, I'm using a, f of a. Instead of m, I'm using the derivative. But other than that, there's no difference in this. So what I'm going to do is go ahead and rewrite my point slope form. But instead of using y1, I'm going to use f of a. So I have y minus f of a equals, instead of slope, I'll use the derivative at a. And then I have x minus, and again, instead of x1, I'll use a. So what I'm trying to do here is get everything in terms of x and y, all right? And then the evaluations are all going to occur around that central a, okay? So now that I have this for my point slope form, again, this says the exact same thing as what I have over here. I'm just going to do one little algebraic thing, and I'm going to add the f of a to the other side. So y would be equal to f of a plus f prime of a times x minus a. And so this is where that formula for linearization comes from. And basically what we're saying is linearization is no different than finding the equation of a tangent line to the graph of a function at a particular point. All right. But we have a purpose for it. Okay. So what we're going to do next is we're just going to go ahead and find the equation of a tangent line to the graph of a function, but we're going to use this format instead of what we've been using for the rest of the semester. Okay, so the function I wanted to use, I thought it would be a good idea to do a little bit of trig review. So the function I want to use is secant of x. And I would like to find the linearization of the secant of x at a equals pi over 3. Okay. And so I want you to approach this in the same way you would have when you found the equation of a tangent line. Okay, so instead of x1, though, we're just calling it a. All right, so we're going to need the y value. all right, because we already have the x value. And the y value occurs when we evaluate the original function at the value for a, in this case, pi over 3. And so that will be the secant of pi over 3. All right, and let's say you're not super comfortable with secant, but you remember that secant is the same thing as 1 over cosine. All right, and then we should remember that the cosine of pi over 3 is 1/2. All right, and that's up to you how you're going to remember those things. You can use the unit circle, the right triangle trigonometry, the tables. There are a lot of different ways that we gave you to try to reinforce that those trig evaluations. And when we divide something by a fraction, that means we're going to multiply by the reciprocal. So 1 divided by 1/2 is equal to 2. So that's the y value for my line. Okay. Now we need to find the slope, but before I can find the slope, I want to find the derivative. And I want to remind myself that derivative is not slope as a numerical value. Derivative is the formula for finding slope. Okay. So I need to find the derivative of my function. And I remember that the derivative of secant is the secant of x times the tangent of x. Okay, so one of the derivative formulas I am responsible for knowing. And now that I have derivative, I can find slope by evaluating the derivative at pi over 3. Okay, so don't forget, slope is not the derivative. Slope is the derivative at a point. All right, and so that will be the secant of pi over 3, which thankfully I already know from up here, times the tangent of pi over 3. Okay, so again, I already figured out the secant of pi over 3. Now the tangent of pi over 3, again, whether you go to the unit circle, the right triangle trigonometry, or the tables, it does not matter. But the tangent of pi over 3 will be radical 3. Okay, so that's my slope, 2 radical 3. All right, and then once I found the y value and the slope, and I already know the x value, I can find the equation of the tangent line. So let's look at this 2 ways. When we first did this, we used our basic point slope form, right? This is how we started the conversation today. So the y value we found was 2, right? The slope we found was 2 radical 3. And the x value that was given was pi over 3. Oops. So we've been leaving it in this point slope form because it tells us everything we need to know. At the point pi over 3, 2, the slope of the tangent line is 2 radical 3. Okay, that's why we use point slope form. Okay. Or now we can use our new linearization formula, which guess what? Won't look very much different. So the linearization formula is when we put a in instead of x1, all right? And we move some things around. Okay, so just a reminder, I'm going to pull that first sheet back up real quick. So this is where we were getting it from, right? When we rewrote as everything in terms of that value a and x, okay? And so that's our linearization formula right there. And our a value in this situation is pi over 3. Okay, and so now we have y equals the f of pi over 3 was 2 plus f prime of pi over 3, which is 2 radical 3, and then x minus pi over 3 to wrap it up. But if you'll notice, these two equations are identical except for the fact that this equation has the 2 added to the other side. So we don't want you to think of linearization as anything different than, excuse me, finding the equation of a tangent line.